Hi, our topic is haptic-based object identification using disturbance observer and deep learning. What is haptic? Haptic is feeling of touch. We humans sense it via skin. It has different dimensions such as texture, temperature, moisture content, and so on. By using it, we can identify objects. We can do basic measurements and also we can communicate via haptic feedback. Our interest is about object identification using haptic features. Sometimes we cannot distinguish objects only with cameras. In here, potatoes and mangoes looks the same. Vision sensors are only one-dimensional. To get additional details, we need haptic sensor feedbacks. With haptic sensor feedbacks, we can distinguish between rotten mangoes and good mangoes. This is how humans identify the object. By touching the objects, we can sense warmness or coldness, roughness or smoothness, stickiness and slipperiness. To identify the shape of object, we are following the contours. Separately identify parts and there are functions and explore the enclosure. From acceleration input, we can observe vibration feedbacks and force feedbacks. Using these, we can estimate weight or inertia. Our focus is on deformation due to force. When we squeeze object, we can observe deformation of object and recovery of object after the force removed from that object. Using those features, we are going to observe the object. In order to measure deformation, we are using disturbance observer and reaction torque observer. So why we use observers? Since observers have higher bandwidth, high impact bearing capabilities, and high system robustness. This is reaction torque observer based control diagram. Here we input force to the motor and receive force response from the object. Reaction torque observer algorithm. This is our test setup: controller PC, motor controller, encoder linear motor, and object itself. Other scholars use these data to create environmental models such as spring damper model and viscose coefficient variations. Also, we can observe largely nonlinear behaviors of soft objects, which cannot be described by spring damper model. Stickiness, crumbling nature, and cracking nature of objects also not discussed using these models. Our approach is to identify key parameters. In order to identify key parameters, we need to calculate lots of possible combinations of parameters and use neural network techniques to identify specific parameters which are more suitable for object identification. Thank you.